James here at Northwest HVAC in Spokane, Washington. Today I'm going to try to be demystifying heat pump boards for you. A lot of people out there get intimidated by heat pumps, don't really like working on them because they don't understand them. They're really not that complicated. Couple of tips here. First, almost all the boards are exactly the same. And as you'll see, we'll go through a few of them, and so long as you understand some basic terminology and you can somewhat read a schematic, it's really easy to figure out what goes where on these boards. And so if we understand the basic operation of them, then we have a schematic, or we could at least trace some wires. We can kind of figure out the functionality of all these different things on these boards. It's not really that complicated to figure out. Second, we cannot think of them as a backwards air conditioner. It's going to help you better in the field if you think of a heat pump as, in the winter time, when it's in heat mode, as a freezer. Think about it. What does a freezer do? It pulls heat out of a really cold area, which that's what outdoors is in the winter, and it takes that heat out of that really cold area and it gets rid of it, it dumps it somewhere else. And that's all a heat pump is doing, is it's pulling heat out of a cold space, the outdoor winter time, and it's dumping it into your house like a freezer would dump to its condenser. Also, it has defrost like a freezer, and its defrost works very much like a freezer. Because like a freezer, we're going to shut off the frozen coil fan during defrost. On a freezer, that would be the evaporator fan. On a heat pump, that would be the outdoor fan. So we're going to go into defrost mode, we're going to shut off that, in this case, outdoor fan on the heat pump, and we're going to defrost. And here in a minute I'll kind of run you through some different boards, different settings on the boards and kind of what they mean, and how I'm going to show you how the wiring is basically the same on almost every heat pump board. And so long as you understand some basic terminology, you can read a schematic or follow some wires. You don't have to be intimidated by heat pumps. They're actually really, really easy. Okay, so for ease of display, I have this heat pump system built on a board with lights that will represent the compressor, the condenser fan, and the reversing valve. So I feel like it'd be easier to explain some things on this board where we can see these bulbs actually come on. Then we can go to a couple of machines and talk about that afterwards. Let me start by zooming in on this defrost board. Even though it looks like a rat's nest of wires, they're all the same, and they all wire relatively about the same. And this one actually is a newer style one, so it has the capability of having the high and low pressure sensors in your system, which I have them bypassed here, but some of the more basic defrost boards don't have that. They're even more basic, which we'll look at a few different styles here in a little bit. But first, we need to get familiar with the basic operation of a heat pump and how the board is wired. And generally, they're all about the same. So once you understand it, then really you understand them all. So let's get zoomed in on that board so we can talk about that first. So I'm going to try to make this as informative as I can. Not just for the students, but because, let's face it, a large percentage, more than 50%, higher percentage than it should be, of people actually working in the field for several years still don't understand kind of how heat pumps are supposed to work and how their boards work. And I see many times throughout the year when my students go on internships, the person they're riding with supposedly been doing this for 5 years and get white as a ghost and scared to death every time they see a heat pump because they don't understand them. They're not complicated, they're easy, but first thing we need to do is understand the terminals. So I'm kind of off to the side over here so we can see the board terminals on the left. But I'm going to start over on the right side with thermostat terminals. And thermostat terminals aren't anything weird than what we're used to seeing on maybe, say, a standard thermostat, right? We have Y1, which we'd imagine would be, you know, yellow, your call for, in this case, it's a heat pump, so I'm not going to say that's the call for cooling. I'm going to say that's the call for the contactor. And we'll see why here in a minute. Then I have a brown wire. It's typically orange. It's on the O terminal. And as we should know the basics of thermostats, O is for your reversing valve on most models. Reem and Rude do it a little bit different. I'm going to be looking at some of those today too. R, as we know, that's your red wire, your power, 24 volt. These heat pump boards are powered 24/7, not just during a call. So they're going to have that 24 volts on them to keep track of memory and timing, things like that, because there is a clock built in. You have to keep track of time. So we got to have constant 24 volt power. Then of course we have a C terminal, which is your common. There is an L terminal on here. On this particular board it's not used. On most boards it's not used. So I'm going to leave that out today. But our C terminal, of course, our 24 volt common, typically your blue wire. And then we have our white wire, W1, which, as we know, that is typically heat. But on a heat pump, you know, the heat pump's your primary heat. So why do I need that stinking white wire out here to control the furnace heat when the heat pump's supposed to be doing all the heating? I'll talk about that in a minute. First, let's talk about these terminals on the side over here. So I have, here it says high, and as you can see I have that bypassed. So that's supposed to be where a high pressure sensor, you know, transducer, thermistor type high pressure sensor would plug in there. And I just have it jumped out, so I'm tricking the board into thinking the pressure's good on the high side, right? Then I have these Y1s, and sometimes on the boards it's just labeled YY. And you can see one of them says out. In between there, I don't know if you can see it, but it says out in between these two terminals. That would be your wires that go to your contactor. So your board, when it wants to control the contactor, it's going to send 24 volts out of that Y1. And it's the top one, I don't know if you can see it on the camera, but the top one's labeled common. So 24 volt common, 24 volt hot on your call for cool out to your contactor. Now DF is your defrost sensor. And again, I have it jumped out because that way I can run it in defrost and make it do all the things it's supposed to do, and it'll respond appropriately. We'll talk about testing in a little bit. But that would be where your defrost termination sensor would go. And that'll be a 2-wire thing, usually a snap disc or a thermistor of some type that would plug in that defrost sensor to tell the board that there's a need for defrost. So the board is going to try to defrost every so often if there's a need. If there's not a need, it'll reset its timer. It'll try again after another period if there's a need. And then at the end of defrosting, that same sensor is going to tell the board, hey, I don't need to defrost anymore. You can go back into regular heat mode now. So at DF, that's very important. That's where your defrost sensor would plug in. The next two spades is your low pressure switch. And again, as you can see, I have that jumped out. So I'm just tricking this board into thinking everything's good on that. And then we have our O, which is our O out. And this would be our 24 volt. This one's not labeled common, so it doesn't really matter. Honestly, it wouldn't matter as far as the contactor or the reversing valve cares if you had these backwards, the hot and common coming off of here. You just need to run those two Y1 wires to the contactor, and the two O wires go to your reversing valve. Next you're going to have is up here, and it may not pick up right on the camera, but there's a section here called fan. And we have to remember the operation of a heat pump is one of the rules for defrost is you got to turn off the frozen coil fan. It's the same as defrost of a freezer for a restaurant or something. When you go into defrost, you kick on those defrost heaters, you're going to turn off the evaporator fans so you don't blow heat around the space while you're defrosting. In this case, we want to turn the fan off because, as we should know, the basics of a heat pump, when it goes into defrost, it basically flips into cooling. So the board will flip it back into cooling, so the outdoor unit now becomes the condenser again, and it's going to be getting hot. And we want that head pressure to get higher because it's cold outside, so we don't want it to be running in a low ambient air conditioning kind of a situation. So it's going to cut the outdoor fan during defrost. So there's always going to be a fan hook up here on the defrost board for the defrost board to turn off the fan during defrost. So we'll talk about some more functionalities in a minute, and then we'll kind of go through you know, how defrost works and what these settings are kind of about. Like this jumper pin over here, that's your defrost test time, or sorry, your defrost run time, but it's also got your test terminal over here. It's how we put it in test mode. So let's zoom back out so we can kind of run it through some basic operation here. You know what? I think we should talk about this first. This jumper pin down here, it says 30, 60, 90, and test. So I've seen this, people make this mistake in the field, and what they've done is they've made the problem worse. So they roll up on a heat pump and it's an ice ball, and they're used to having defrost timers in refrigeration where you can set the amount of defrost time. And they see that it's set for 30, and they say, oh, well, the problem is it's not running in defrost long enough, so I'm going to change it to 60. What they've actually done is made the problem worse, because these heat pump boards, they have a built-in timer of 10-minute long defrost. That's not adjustable. It's not something we can adjust. What this pin here is for is about our run time. Here in our area, we have a colder winters. It gets lower temps, so we want to probably have that set for 30. Somewhere milder, we might have 60, and then, you know, down south in Florida, then we could set it for 90. But what this is every 30 minutes of run time, it's going to try to defrost. And we talked about that sensor earlier. If the sensor is showing closed or low ohms, then the board is going to go, okay, I'm frozen, I need to defrost. If it's not, what will happen is the board will shift into defrost, and then within a couple of seconds, it'll kick right back into regular mode again, and it'll start another 30-minute timer. So basically, this board right now is set for 30. It's going to try to defrost every 30 minutes of run time. So like, let's say it runs for 10 minutes, then 10 minutes, and then 10 minutes again later. When it hits that 30-minute run time mark, not real time, run time, then it's going to try to defrost. And if the sensor says, yes, I'm frozen, it'll go ahead and defrost until the sensor says no, says that it's thawed out, or until that 10 minutes goes by that's programmed into the board. We can't adjust that. So to start with, my board is set for 30. It's going to try to defrost every 30 minutes. If the sensor is showing closed, it'll defrost until the sensor shows open, or until that 10-minute timer goes by that's built into the board itself. The test right there is how we test defrost. When this thing's calling for heat, when you have a normal defrost sensor, you're going to need to jump out the defrost sensor like I have here. I put these two red wires here jumping out my defrost sensor, but you can do it with just some jumper wires. Because if the defrost sensor reads open, like I said a second ago, it'll go into defrost for you, but then it's going to shift immediately right back out, and you won't be able to get any testing done or anything you're trying to do by testing defrost. So you have to first jump out the defrost sensor to trick the board into thinking that it needs to defrost, and then you move this jumper pin over and put it on the two test pins, and you just wait a couple of seconds and it'll shift into defrost for you. So I'll show you that in a minute. Let's zoom back out so we can look at the whole thing in action. So we mentioned earlier that W wire on the thermostat wiring. On this one it's labeled W1, sometimes it's labeled W2, and with Reem and Root it's actually labeled D. Why would it be labeled D? Because for defrost. we talked about defrost earlier. When the heat pump goes into defrost, it's going to shift into cooling. It's going to turn off that outdoor fan to get the head pressure up, because we're basically running AC now in the winter time. And as we should all know by now, ACs don't like when it's cold outside. So we cut that outdoor fan, it gets the head pressure up. It also puts more heat onto that outdoor coil to help it defrost faster. But the other thing we do, because we're running in cooling mode, we're basically blowing cold air in the customer's house, or technically removing the heat from the air in the customer's house, and they're going to feel cold air blowing. So the heat pump board will then send the W1 signal back inside to the house to turn on the backup heat to temper the air during defrost, and so the customer doesn't feel cold air blowing. Now, the other thing the W-wire does on some of the more modern heat pumps is some of these more modern heat pumps have an outdoor temperature sensor built into their board. And those are set from the factory at whatever their COP, their balance point is, so that when it gets to a certain cold outside, the heat pump board will lock itself out and send that signal back in on W to run the auxiliary heat. So it'll basically run emergency heat for you. This board doesn't have that option. It doesn't have the outdoor sensor. But some of the newer heat pumps do have the outdoor sensor, where they'll literally, when it gets too cold outside, they'll just stop running the heat pump part and they'll send that W signal back indoors. So the W on the board has two functions. One, to turn on the backup heat during defrost, so we're not blowing cold air, quote unquote, onto the customer, while we're essentially running cooling during defrost. And the other function on the newer boards of that W is going to be to, if it gets too cold outside, the heat pump will lock itself out. It'll send that W back in and run your backup heat, because that would become more efficient than your heat pump once your heat pump drops below its COP. And I'm not going to get into COP and balance point right now, but just know that the heat pump is usually the more efficient way to go until we get a certain cold outside. Then the board says, nope, I'm not efficient anymore. I'm going to cut myself. I'm going to run that W back inside. But the primary function of the W is to temper the air, run the backup heat during defrost. Okay, so the Y wire is going to actuate your contactor in either mode, heating or cooling. The O wire is going to actuate your reversing valve, in most cases in the cooling mode. So most units are set up to fail into heat, which means if you call for heat, it's just going to run the contactor, not the reversing valve. And it's going to be automatically in heat mode. When you call for cool, then the thermostat's going to send 24 volts for the contactor and for the reversing valve. And then the board's going to see that. It's going to send power to the contactor and the reversing valve. It's going to reverse the valve into cooling, and you're going to be in cooling mode. During defrost, what the board does is it sends power to that reversing valve to kick it into cooling. Or in the case of Reem, it's going to take away power from the reversing valve to get it to go into cooling. Because Reem is backwards, it fails into cool. We'll talk about that a little more later. I want to start with what we have here is a reversing valve right there. We have, this one's labeled compressor, and this one over here is the outdoor fan, the condenser fan. And so we can see when we run normal mode that everything's going to actually we'll start with cooling mode. Because cooling mode with this typical board, non-Reem board, it's going to actuate the compressor, the condenser fan, and the reversing valve. Everything's going to pop on. So let's kick this thing into cooling mode. So, happy accident. One of the students screwed with my contactor. There we go. So, we see we have the reversing valve light on, we have the compressor light on, we have the condenser fan light on. When I go to heat, you can see that it cuts the reversing valve. So we're failing into heat mode. So we're still going to run the compressor and the condenser fan but we're gonna cut that reversing valve now. We're in heat mode. And if I switch back to cool mode, hopefully it doesn't wig out my thermostat, then I re-energize my reversing valve. You're gonna hear that whoosh noise. We're gonna go into our call for cool. So let's put this back in heat. And since I have my defrost timer or my defrost sensor jumped out, then the board thinks that it needs the defrost. So we could wait here for 30 minutes to go by, or I could just hit the test button and we can see what happens. So right now, imagine that we're burning away in heat mode. We got our compressor on, our condenser fan is on, but my reversing valve is not on because I'm failing to heat mode. So I'm running in heat mode right now. Reversing valve is not energized. When it goes into defrost, we first jump out our DF sensor, and then we would take this jumper pin, we jump it over here to these test terminals. And that should cause it, there we go, to go into defrost mode. So now it kicks on your reversing valve, switching it into cooling, and it turns off your condenser fan. And you see how fast that kicked back out? If it's not actually frozen, it's going to kick back out after a while. But we can see that it cuts the condenser fan. And then when it goes back out of defrost, and I have it like that on purpose, when it goes back out of defrost, then it'll kick your condenser fan back on, kick your reversing valve back off. Defrost, and then out of defrost, and it'll kick your condenser fan back on. So it's going to control your condenser fan every time. Now just to show you, I have disconnected the jumper on the defrost sensor, and look what happens when I jump it into defrost test mode now. Nothing. Because you remember, you have to jump out that defrost sensor first to trick it into thinking it needs the defrost. Now when we jump that out, it should be able to go into test mode again. There we go. Reversing valve comes on, condenser fan goes off. And of course that's going to kick back out because kind of the way I have it set up. But if the coil's frozen, then it's going to stay in defrost, not through test mode, but through normal defrost mode until it's either thawed out and this defrost sensor then comes loose and says, okay, doesn't come loose, but you know, the ohms go back high again. It's an NTC thermistor or a snap disc. So it'll either open when the coil warms up to 55 degrees or the ohms will go really high from it being a thermistor. Either way, that's how it tells the board that it's defrosted. And if that doesn't happen within 10 minutes, then the timing of the board will then switch it back to normal mode after 10 minutes. Now keep in mind, most boards do this. They're only going to go into defrost for a second or two. There are some out there that'll stay in defrost until you reset them. But a lot of them, they're just going to go, because when we're testing defrost, what we're doing is we're just testing, will the board go into defrost? So basically what we're trying to do is we're trying to make a determination as to if the board is good or not. If I jump this out to test mode and nothing happens, then I know I have a problem with my board. Right? The other thing I can look at is if I jump it out to test mode, and I've had this happen before, jump it out to test mode and that condenser fan doesn't go off because the switch of the relay is stuck shut. So that we know the condenser fan is supposed to go out during defrost, so that relay could be stuck shut. The other thing we could be having, but this one's pretty more obvious because your condenser fan is not running to begin with, is the relay could be stuck open. So it could be not having power, and that's what happened in my house is the relay was stuck open. It wasn't sending power to the condenser fan at all. So I had to change the board out. And it was actually the fan going bad that took out the relay, arced out the relay and made it get stuck open. So weird things can happen, but if you test it and it shifts into test mode, or it shifts into defrost during test mode, reversing valve, you can hear it whoosh, your condenser fan goes off, then you've proven that the board is functional. That doesn't necessarily mean there's not other things wrong with the board, but the board itself is doing what it's supposed to do. So now we can look at some of these external components, like the high pressure switch, or the defrost sensor itself, or the low pressure switch, or maybe the reversing valve, or whatever might be the cause. But we have to first start by understanding what these terminals mean on here, and that's 80% of the battle probably. Understanding your stat wires, what is Y, what is O, what is R, common, what is the function of W1 or W2 or D if it's a Reem, and then over here how this is wired with the high pressure sensor, the contactors your Ys, DF is your defrost sensor, low is your low pressure sensor, and then O out goes to your reversing valve. And right now I just have my reversing valve set up as a little 24 volt relay because, as we know, light bulbs are not 24 volts, right? So that's the gist of it. In cooling mode, well, let's start with heat mode. In heat mode, it's going to run like a typical air conditioner would run in the summertime. It's just going to energize the contactor and nothing else. So the compressor is going to come on, condenser fan is going to come on, but it's already in, its reversing valve is default in heat mode. So when it comes on, it's going to come on in heat mode. When it goes into defrost, as we saw earlier, it's going to kick off the condenser fan. It's going to kick on the reversing valve. It's going to switch that off. It's going to go into cooling mode now until it's defrosted, or until that timer's up in the board, which is 10 minutes. Then in cooling, we're going to have everything actuated. Compressor will be on, condenser fan will be on, and your reversing valve will be on. So a couple typical things that confuse people on heat pumps is what's that W wire doing? The functionality of it, the fact that that jumper represents 30 minutes of run time, not 30-minute defrost time. What these letters mean, right? Your high pressure, low pressure, your defrost sensor. Once we can get past all of our understanding of that stuff, then the basic functionality of a heat pump, we need to know that the board is controlling the fan. Yes, the power for the fan still comes off the contactor. If the contactor doesn't pull in, there won't be power for the fan. But on your typical AC, that contactor is going to send power directly to the compressor and directly to the condenser fan. On a heat pump, it just makes a detour, and it comes off the contactor through the switch on the board before it goes to the condenser fan. So we got to remember that if we're having issues with our condenser fan on a heat pump, but yet the compressor is coming on a typical AC, we would go, oh, well, that's a problem with the fan motor because they're wired in parallel directly and there's nothing else in the way. On a heat pump, though, you have to go, wait a minute, is it the fan motor or is it the board stuck open, not sending power to the outdoor fan motor? And then the low and high pressure sensors are simple enough. Defrost sensor is simple enough. It's basically when it reads closed, which should be really low ohms, then the board says the board knows it's frozen, and which is usually below about around 25 degrees, and that's coil temp, not outdoor temp. And then when the defrost sensor reads really high ohms or open, depending on the kind of sensor it is, then that tells the board that it's over 55 degree coil temp. So they typically, the board reads it as closed with a 25 degree coil, and the board reads it as open with a 55 degree coil. So let's look at some other boards on some other machines that are actually in machines. So here we have a standard non-Reem, just a generic board. They're doing some things a little bit different though. So if we understand what the board is supposed to do, earlier with the light, with that light board over there, I showed you the basic functions of what it's supposed to do. So now if we understand what the board is supposed to do, then we can make sense of these weird labeled terminals. So I still have my jumper pin over here, my 30, 60, 90 in my test, okay? And then I have underneath, I have, I got R and W and Y and O from the thermostat, just like I would normally have. And then I have C from the thermostat. It was hard for me to get my camera in here for you guys to see that, so you just have to take my word for it. We got R, W, Y, O, and C from the thermostat, just like any old heat pump. And then what this one's doing a little bit different is it's got O out. It's got an O with a little RV next to it. And it's sending power out of that terminal down here to the reversing valve cable. And then it's coming back just to common on the contactor. So it's actually not even, here, let me see, let me come down a little bit so you guys can see that. So it's coming out on this cable here from the board out the O terminal, and instead of like the other board had the 2 terminals for the reversing valve, this one just has the 1, and it's going to send that O out through this cable to the reversing valve, and then the reversing valve just comes back and it terminates right here next to common on the contactor. And that's very common, like a Goodman thing that I see a lot on Goodman. So instead of having the 2 terminals for the reversing valve, it's just got, it comes back to here. And the on the contactor, it does the same thing. So the contactor is actually sending its Y signal down here to the contactor. It only has the one Y, and it's just grabbing all of its commons off the board. The board's common is coming down and linking up here, and then the reversing valve's grabbing it here instead of coming back to the board. Very common. So all we got to do is follow the wires though, and or the schematic, and it would tell it, it would show us that the R, or sorry, the O is going to the reversing valve and then is coming back to common on the contactor instead of coming back to the board. The other thing that this one does a little bit different is down here, it's got DFT and it's got R with a small DFT, and that's right next to the R terminal. So that would be your defrost sensor, your defrost termination sensor. That's what DFT stands for, defrost thermostat or defrost termination. Then this one is just running that R signal through the defrost termination sensor and getting it back on the DFT terminal. And so it could still be a thermistor or a snap disk. It basically, when it reads as open and it doesn't get that signal back here, then it knows that we don't need defrost. We're warm coil. But when it does get that signal back here, then it knows it needs to go into defrost. And then over here, before we had the fan, it just said fan, and where you had your 2 things to plug in. This one's a little bit different. It says DF1 and DF2. Now, how we don't get that confused with the defrost sensor is we have to be able to follow our wires. If we look, DF, it comes off. I don't know if you guys can see it. Let me kind of pan out so you can see that. So that DF, it comes off of here, and you can see it comes down to the high voltage lug of the contactor. So it can't be the defrost sensor because that's low voltage. So we have to, knowing how the system works, we have to know that that DF, in this case it's DF2, coming off power of the contactor, and then it goes through this switch, and then that DF1 is actually feeding down here into my cabinet to my condenser fan. So instead of being labeled fan, this one's labeled DF1, DF2, and then down here we got this DFT. So to keep it straight, the schematic should tell you if it's the original board, But to keep it straight, the DFT, that's your sensor. This DF1, DF2, we can clearly see one of them runs the high voltage, so that must be my fan relay. Plus, if you look close enough, you can see there's a black relay right there, and typically your fan wires are connected right next to a big black relay like that. The last little bit that's weird on here, a little bit different on this one from the last one we did, was over here it's got a PS2 and a PS1 terminal, and that's for a pressure switch safety. Very clearly labeled PS1, PS2. And then, but that's the basics of it. You're always going to have your W, you're going to have R, O, C, and then you're going to have some kind of way to turn off that condenser fan, and you got to have some kind of defrost termination sensor. You may or may not have a low pressure switch hooked up. In this case, we didn't need to have one. And usually if it has it on the board though, you're going to have that pressure sensor. I don't really want to get into how to test those right now. I'm focusing on boards for this. If we understand how a heat pump's supposed to work, and then we understand how pretty much all boards are wired, then that should take away the stigma of heat pumps. And then instead of 80% of us don't know how to work on them, maybe only 40% of us will not know how to work on them after this. So let me show you how Reem is a little bit different. Okay, now lastly we have a Reem. Now Reem and Root are basically the same, but they do everything backwards of everyone else. So most manufacturers are going to fail into heat mode, which means their reversing valve is not energized in heat mode. It's only energized in cool mode. Reem does it the opposite, and I don't want to get into the logistics as to why they do that, other than just to say that I agree with their philosophy on why they do that. But they're the only one that does that. Everyone else has fail into heat mode. Reem is fail into cool mode. Now the first thing I want to point out is this one has the outdoor sensor I was talking about earlier. So this one's going to lock itself out when temperature gets too low outside, and it's going to kick on that backup heat for you. We'll talk about that in a second. But we can see that that thing's plugged in actually up here on a clip. So this clip, I can't see the title of it, but I'll look at the schematic here real quick. It's labeled AS, as an ambient sensor. Ambient sensor. So then we have another one right here that's labeled DS. It's our defrost sensor. Okay, now we know that DS, defrost sensor, and actually there's a legend on the board here for the LED codes, but the panel of the unit tells us what all this stuff means. Then of course we have our Y, and we have B, and then we have D, and R and C. So Reem, instead of doing O, they do B. And on your thermostat, when you program it, you have to set it for O or B, because the thermostat needs to know if it's energizing the reversing valve in heat mode or in cool mode. So for Reem, it fails into cool mode. It's going to energize the reversing valve in heat mode, which is opposite of what we've been looking at so far. And so they're going to be a B terminal instead of an O terminal. The other thing that we saw is different. It's got a D instead of a W, and that just stands for defrost. It's going to work exactly the same way. That's going to send your W signal in during defrost to temper the air so you're not blowing cold air on the customer during defrost. Also, since this one has that outdoor sensor we talked about a second ago, that's also going to be when this thing gets too cold outside, it's going to lock out the heat pump part of it. It's going to send that D signal back inside and run the backup heat, the auxiliary heat, or emergency heat, depending on how you have it set up. And then we have up here, we got an RV and a C. So that's clearly hot and common for our reversing valve. And And then we have LPC and HPC, which is our low pressure and our high pressure sensors. And then on the very bottom here, we have our Y out CC. So that just means that's your power to your contactor. That's your 24 volts coming out to your contactor. And again, on the contactor end of things, it doesn't care which direction you poke those wires in. One's going to be hot, one's going to be common, and the contactor doesn't care which one's which. So there's nothing you can do wrong there. Your high and low pressure switches, if you get those wires backwards, nothing you can go wrong there. Reversing valve, same thing. If you get those backwards, nothing you can go wrong there. The only thing you can go wrong on, but you can't, is because these clips here are the two sensors. They only plug onto the board in a certain way. So you can't put them on backwards, but they're designed to only clip on one way, unless you rip on them like some students did, and then you make it all dislodged and crappy. But aside from that, good to go. Now down here we have two fan terminals. It says fan and fan, and that would be where your condenser fan plugs in. And as you can see, this one's white instead of black, but it's always right there next to a relay. So you got that relay on the board that controls your fan during defrost. So on this one, on a call for heat, it's going to have the reversing valve energized. Condenser fan will be closed, compressor will be running, everything will be running. Then when it goes into defrost mode, it's going to de-energize the reversing valve and de-energize the fan. But it's all the same concept. You just have to understand that Reem and Rude do it backwards. They have the B instead of O, and they have D instead of W, but every other function on this board is exactly the same. You just have to remember that with Reem, it's going to be sending 24 volts to the reversing valve during heating, and with everyone else, it's going to be doing that during cooling. And so, of course, from there we can deduct that during defrost, it's the opposite. So during defrost, Reem is going to not send 24 to the reversing valve, and everyone else is going to be sending 24 volts to the reversing valve during defrost mode, because defrost is just cooling. So there you have it. Hopefully that was informative enough for you. I can't really go too much into the operation of a heat pump that I haven't already covered. I think it's mostly the boards and how they're wired and the things that are on them and how you test them and where they go and whatnot. That is what people struggle with. So I think the concept of reversing the refrigeration isn't necessarily a tough concept. I think it really comes down to the controls, because your standard AC, it doesn't have a board. It's very simple. Y from the thermostat energizes the contactor, it pulls in, the thing runs. Defrost is a little more complicated. It's got sensors attached to it. It controls the outdoor fan. It's got that reversing valve thing going on. So it's got various different components that are wired back to the board. But if you understand those components, the terminology on the board, and the basic function of what that board is supposed to do in the heat pump, it's actually really not that difficult. So hopefully this video was informative enough for you, and I guess if not, I might try to do a part 2, go into a little more depth, but I feel like you should have a pretty good understanding of it just from this video alone. So thank you very much. Appreciate it.